Alright, so we're going to start 2.1, linear and quadratic functions in modeling. So most of this lesson, maybe all of it, will look familiar. Some of it was actually going to be a little bit of a repeat from last chapter, so hopefully this goes really well. We're going to start off with writing linear equations from 2 points. And we're specifically going to use slope form. Point slope form is y minus y1 equals m x minus x1. That is point slope form. We're going to need to use that on our first problem. Our first problem says we're trying to find the slope form of the equation of the line going through these two given points. So I need to find the slope first. My slope formula is y2 minus y1 over x2 minus x1. Let this be x1, y1, x2, y2. So if I plug in slope formula, y2 is negative 1 minus negative 2, so plus 2. And then x2 is 0 minus 1. So I end up with 1 over negative 1, or just negative 1. And if I plug into my actual point slope equation, y minus y1 equals m x minus x1. So y minus y1 is negative 2, so plus 2. My slope is negative 1, so negative x minus, and then x1 is 1. So that is my equation in slope-intercept form, or in point slope form, sorry. Go ahead and try the rest of the problems in this section. So I think that's numbers 2, 3, and 4. Go ahead and pause the video right now, and then I'll show you the answers for those. Alright. For number 2, you should have y plus 4 equals 2 times x plus 4. For number 3, you should have y minus 4 equals 1/2 x minus 5. And then for number 4, y plus 1 equals 1/6 x minus 1. If you have any questions on those, just send me a message on Remind, and I'll try to post a video on how to do those. Alright. Next, linear regression. So linear regression is if I have a series of some x and some y values, and we want to come up with a linear equation for that. We are going to use our calculator, so if you haven't already, you're going to need one of the TI-84 calculators. And we're going to have a list of steps to help you do this. So step 1, you're going to go to Stat, and then the very first thing on the list should say Edit. Number 2 on the list is you're going to clear out L1 and L2. I'm going to talk about how to do that in a second. Step 3 says to enter x into L1 and y in L2. So our x values go in list 1, our y values are going to go in list 2. Step 4 is we're actually going to hit the stat button one more time. We're going to go right arrow, which should take you to the calc. tab. See at the top there should be 3 tabs. The middle one is the calc tab. And we want option 4, which should say LINREG. And then once you get there, we're going to go to step 5. At the very bottom, it should say calculate. Now, that seems really confusing. That's okay. We're going to go through a problem together. So now this is it. Okay. So if I bring up my calculator, go to stat, enter. I see I already have values in for L1 and L2, so I'm going to go up, I highlight L2, and I hit clear, enter. Now it's important to use clear, not delete. If you hit delete, you'll delete the entire list. So use clear, enter, not delete. And then for L1, I'm going to enter my X values. 0.5, 1.2, 2.5, 2.8, make sure you put 8.2 in twice. Alright, so at the very end, when I get to a little dotted line after I put everything in, mine says L1 equals 15, which is good because that means I should have put 14 data points in. I'm going to go right arrow and do the same thing, but I'm putting the Y values in now. Alright, and then when I get to the end, those two dotted lines should be beside each other, showing me that I put the same amount of values into L1 and L2. If you don't, it'll give you an error on this next step. Alright, so our fourth step was to hit stat button one more time, right arrow to the calc tab, and then go down to number 4, or just click number 4, and then go down to calculate. And I should get that right there. Now this is important to note that if you do this and you are missing this right here, so maybe you only have y, a, and b, you're missing the r and the r squared. I'm going to show you how to get the r and the r squared. You would hit the second button and then 0. Second button 0, and you'll see this. And you need to scroll down to the d's, or you can shortcut that by hitting this x to the -1 button, or the one that has the little green D on it, and it shortcuts you to d's. And we're going to scroll down to diagnostic on, not diagnostic off, diagnostic on. Hit enter again, and it should say done. And now you can hit stat, go over to calc, scroll down, and now if you didn't before, you should have the r and the r squared. Okay, so let's think about what that r and r squared means. R tells me how strong my correlation is. So I'm going to clear this thing out right here. let's say I had two different scatter plots. Okay. Well, for this first one, I would draw a line of best fit, something like that. For that second one, I have no idea how I would draw the line of best fit. Maybe like that, maybe like that, maybe something in between. I don't know. You'd draw a line of best fit some way, but it wouldn't be a very good line of best fit. So because of that, we would say that this has strong correlation, meaning that all those different dots are close to my line of best fit. Where over here, I draw a line of best fit, and this would be...
Attention students, if you are attending seat time today, you need to report there within the next minute.
Or no correlation.
Thank you.
Okay, and for this one, I would specifically say that it is no correlation. Okay, so the further away from the line those points are, the weaker my correlation is until I get to something like this, no correlation. Well, R is very useful because it tells me how strong the correlation is. It also tells me the slope of the line. So for this first one, I see that my line is going down, which means that I would have negative slope, or my R would be negative. Because they are very close, this one would probably have an R of about, say, 0.96. Okay, this one's very weak, so this one is still going down. Would have an R like 0.2 or 1. Okay, R values go from -1 to +1. If it is at +1 or -1, it is perfect correlation. That means every single point is on the line. If it is at 0, it is at perfect no correlation, which I've never actually seen happen before. But in theory, if it was on 0, it was perfectly no correlated. For our purposes, if it is between -0.5 and +0.5, we call this range no correlation. Okay, so if the first number you see is a 5 or lower, 0.5, 0.4, 0.3, 0.2, 0.1, or 0, then we call it no correlation. If I get a little bit wider, I have values going from -0.7 to -0.6, or on the other side, +0.7 to +0.6. So my R is somewhere in this range. We will call that weak correlation. Okay. Think of correlation as a test grade. If you got a 63 or a 72 on a test, you did fairly weak on it. Technically, both of those are passing grades, but as a fairly weak grade. Something less than 0.6 would be something that started with like 0.5. So a 52 or a 47, all of those would be, you knew nothing on the test, so no correlation. And then my last group is, well, what if I got a B or better on that test? Meaning, what if I'm at -0.8 or +0.8?
Mr. James, please report to the main office.
What if I'm on that range?
First Sergeant James to the front office, please.
If I'm on that range, we call that strong correlation. So going back to the problem we did, I see that my R is 0.167. Well, 0.167, if you made a 16.7 on a test, you knew basically nothing that was on that test. So we would call this problem no correlation, because my R was 0.167. Okay, no correlation. Alright, it also wants me to find the equation of the line. Well, the equation of the line they actually give me. My line is going to be y equals A, which is 99.132x, and then plus the B, and our B is 4378. Because that's such a big number, I'm just going to round to like 1 decimal place. Normally I round to 3 decimal places, but I have thousands, I'm not going to bother. That would be the equation of my line of best fit, which doesn't mean a whole lot because it is no correlation. But we're going to show how to graph a scatter plot, and we're not actually going to do this by hand. If you want to, you can use the graph provided, but I'm just going to use that graph to show you what your answer should look like in the end. So I'm going to make a scatter plot using my calculator. To do that, I'm going to hit y equals, clear out whatever's there, and type in my line of best fit, which is 99.132x plus 4378.4. And then I'm going to go to second y equals, and it brings up that. And again, if you missed it, second y equals. Hit enter. And this tells me in type all the different types of graphs my calculator can do, but I'm just going to stick with the first one. So all you should have to do here is hit enter to turn your this on. And then I'm going to hit graph, and probably nothing will happen. I get a blank graph, and the reason why is my equation and my points are way off my graph. So I'm going to use the graph they gave me to figure out a good window to look at this. So I'm going to hit the window button, which is right beside y equals, and look at their x values. Well, their x values on the graph go from 0 for x min to 10 for x max. Their y values go from 0 to 9,000. So now I'm going to hit graph. I see some data points pop up, and I see what my calculator gave me as a line of best fit, but I also see that those points are pretty far away from that line. So I want you to do that same thing for the next couple of problems, and then I'll put the equation on here so it'll look like this on there. Now zoom out a little bit, and it should say your equation 2. Okay, so go ahead and pause the video here, try the next couple problems, and then hit play whenever you're done. Alright, so for number 6, you should have gotten that it's positive correlation. You should have gotten that as your y equals. And if your y equals looks a little bit different from theirs, that's okay. Your r squared might be a little off as well, because of what they use to calculate these regressions might be different than what we use. But they should still be fairly close, especially your r equals. Alright, and of course your line of best fit would be going through there as well. Number 7 would be negative correlation. See that my line of best fit would go down. There's my y equals and my r equals. This would be really strong correlation. This is positive correlation, but because it's a 0.7, it would be weak correlation, because that r equals is negative 0.713. It would be weak positive correlation.